Hello Paulinians, I'm Ma'am NJ. Our topic for today is about lesson 1-1, which is quadratic function. Let's define quadratic function. A function characterized by a second-degree polynomial equation useful in modeling situations where the rate of change is not constant. And it is formed as f of x is equal to ax squared plus bx plus c, where a, b, and c are real numbers and a is not equal to 0. So let's have some example. Tell whether the function is quadratic or not. So example letter A, f of x is equal to x squared minus 3. So for the solution, this function is having second-degree polynomial equation. It means it is a quadratic function with a is equal to 1, b is equal to 0, and c is equal to negative 3. Another example, g of x, it is the same with f of x. G of x is equal to square root of x minus x plus 1. So it is not a quadratic function because it has no second-degree term. As you remember, quadratic function is characterized by a second-degree term. So if the given function has no second-degree term, it means it is not quadratic function. Another method to identify quadratic function is the equal differences method. We have here a table, and we have the value for x, which is 0, 1, 2, 3, 4, 5, 6, 7, and 8. And let's assume that f of x have these values, which is 8, 6, 6, 8, 12, 18, 26, 36, and 48. Now, let's find the differences in x. So we have 8 minus 7 is 1, 7 minus 6 is 1, 6 minus 5 is 1, 5 minus 4 is 1, 4 minus 3 is 1, 3 minus 2 is 1, 2 minus 1 is 1, and 1 minus 0 is 1. As you notice, the difference in x are the same, which is 1. How about the difference in f of x? So let's try. 48 minus 36 is 12, 36 minus 26 is 10, 26 minus 18 is 8, 18 minus 12 is 6, 12 minus 8 is 4, 8 minus 6 is 2, 6 minus 6 is 0, and 6 minus 8 is negative 2. As you notice, our first differences in f of x are not the same. So let's try another differences. So we have 12 minus 10 is 2, 10 minus 8 is 2, 8 minus 6 is 2, 6 minus 4 is 2, 4 minus 2 is 2, 2 minus 0 is 2, and 0 minus negative 2 is 2. For our second differences in f of x, we have the same value, or it is equal to each other. So now we can say that this is a quadratic function. Based on the table of values, equal differences in x results to equal second differences in f of x. This property of second differences holds for all quadratic functions. Another example, compute for the first and second differences in f of x. We have the value for x, which is 0, 1, 2, 3, 4, 5, and 6. Here's the value for f of x, negative 1, 0, 7, 26, 63, 124, and 215. The differences of the value in x are the same, so it is equal to 1. Now, let's find the differences or the first differences in f of x. We have 215 minus 124 is equal to negative 1. 124 minus 63 is 61, 63 minus 26 is 37, 26 minus 7 is 19, 7 minus 0 is 7, 0 minus negative 1 is 1. So, the first differences in f of x are not the same. So, let's try second differences. 91 minus 61 is 30, 61 minus 37 is 24. 37 minus 19 is 18. 19 minus 7 is 12. 7 minus 1 is 6. So, since the second differences in f of x are not equal, therefore, f of x is not quadratic. Remember that using the equal differences, you need to find or compute the first and second differences in f of x to identify whether that function are quadratic or not. I hope that this lesson will help you for the future lessons, and I'm hoping that you enjoy learning with me. Thank you for your time and see ya!